In this question we're going to look at perspective. This is the 2018 higher level perspective question. Now first of all, if we look at the question itself, it is draw the plan and make a perspective drawing of the following structure. So this here is a building in Dublin. So what we have looking at the edges here, they're sloping edges, so we're going to be using auxiliary vanishing points. Now what's interesting in this one is in plan view here we have lines going back here at an angle, then we have these lines going back at a different angle. So this does cause a bit of an issue because in this question we will need 3 vanishing points in order to draw the object. Now the second part of the question is there's a chimney positioned in position C here, and what we have to do is you're told it's 20 meters high, so you just have to draw that chimney in perspective. We'll have a look at how you do that. And then the last point here is the angle of elevation when you're viewing the top of the chimney from S. So basically it's going to be a line from the spectator to the chimney to see how much of an elevation there is in that. Now, so before we start, we'll have a look at the marking scheme. So the marking scheme is here. So if we look here, the first section here is draw the required plan, 15 marks. So a third of the marks are going for drawing the plan. So you draw the outer portion of the plan, 6 marks, the inner portion then 3 marks, and then draw the plan of the spectator, picture plane and the vanishing points. So there's quite a lot of marks, easy marks to pick up there. Then the perspective of the drawing is worth 27 marks. So that's ground line, horizon line, vanishing points. Then we'll say start to draw the front edge of it, then using your vanishing points to find different surfaces, then completing different faces. Then the perspective of the chimney stack is only worth 2, which is still an easy 2 to get. And then the angle of elevation, there's 1 mark. A lot of students wouldn't find this in the exam, but we'll show you how easy it is actually. Here you can see I have the plan already set up. Now it would be advisable to have this fitted on an A2 size paper because it is quite large. I have it on A3 here, but I have the page put on portrait. So you have to keep the plan up near the top of the page. Now also what I have done to make life really easy for me is on my drawing sheet here I've converted all the measurements. So all the measurements are in meters and the scale here is 1:200. So that means we take our measurements here, so 10 meters, change it to millimeters, so that's 10,000. So it's 10,000 divided by 200, which gives us 50. So this is a quite good thing to do at the start of an exam, to actually change all of these measurements to mils. It will actually speed you up to change them to the correct scale that you need to draw them at. So we have 25, 15, 50, 15, 70 and 100. Now also over here as well, where you're told that the spectator is 20 meters away, so that's 100 mils. You're told that the horizon line is 50 meters, so that's 50 or 100 or 10 meters, sorry. So that's 50 mils above the ground line. Now the other thing as well that I've done in part B here is the chimney stack. It's 20 meters, so what it is here is 100 mils. Now so if we show how to create vanishing points in this situation. Now the first vanishing point I'm going to set up is a vanishing point for this edge here, this edge and this edge. So that is done by getting this at 30 degrees and bringing a line here 30 degrees onto our picture plane, and this here is the position for the vanishing point here on the picture plane. So we'll call that VP1. Then we need to create 2 more vanishing points. So the two more vanishing points in this question here. Is the first one has to be for this edge here. So what we have here is we have the set square set here at 70 degrees. Now the reason it's set at 70 degrees is this is tilted at 30 degrees. We are told this is 80 degrees inside here. So 80 and 30 is 110. So that means the remainder of this has to be 70 degrees. So these lines are drawn at 70 degrees. So this edge is at 70 degrees, this edge is at 70 degrees. So from the spectator, bring up a line parallel and mark off the position for the vanishing point. We will call this VP2. And then to find the third vanishing point, and the reason why there's three vanishing points in this question is this edge here is not parallel to this vanishing point here, nor is it parallel to this vanishing point, but it needs to be vanished in a particular direction. So we need to find a vanishing point for it. So to find a vanishing point for it, we just take our adjustable set square, set up and then from our spectator set up our vanishing point. So in this question here we have VP3. Now if we bring down them 3 points by setting up our adjustable set square to the picture plane, and what you will notice here if I zoom out, I have my ground line set up, and I'll bring down my vanishing points onto my horizon line. So I have my horizon line set up here also. So my horizon line is here. It's up 50 from the ground line. So what I'm going to do is bring down my vanishing points. So vanishing point VP2 is marked off here. VP3 is brought down here. And we'll bring down VP1. So VP1 is brought down here. So again, we'll mark in our vanishing points. So VP1, VP2, VP3. Now we're going to start with the easiest section. So the easiest section is the front edge here, edge A here. If we bring this edge A here down, it's on the picture plane, so we can bring this straight down. If it's touching the picture plane, that means it's touching the ground line. Now what we do know about it is it's a height of 25 mil, so we can measure up our 25 mil. Draw our front edge of the building, and then we can vanish it back. So we're going to vanish the front edge here back to VP1, top edge here, and then we have to determine which vanishing point we're going to bring the rest of this back to. So I know we're drawing this piece of the building here, so I know it has to be this vanishing point. So it's this point here. So if I take my set square here, and all I'm going to do is vanish back the base of this, I know the top edge is at an angle. Now what I'll do now is I'll bring down my points, join them to the spectator point. So I'm joining these points to the spectator, mark them on the picture plane. So this is the outmost corner. Do the same on this point here, and then bring down these 2 points. So this point brought down, and then we bring down this point. Now we'll draw the front of the structure here. So the front of the structure here can be drawn in heavy. And then the side of the structure, all we can draw for the moment is this baseline here. Now, so basically all we can draw so far is this much of the structure. Now, we now need to start looking at the drawing itself. And if we look at the drawing here, we'll realize that we have the front piece drawn. Now we need to draw this edge here, possibly this edge. So if we look here at what's given to us in the question, we'll notice here this must be joined to an auxiliary vanishing point. This is also joined to an auxiliary vanishing point. So we need to see how we locate these auxiliary vanishing points now. So if we go back up to the plan view and our spectator, now we need to get an auxiliary vanishing point for this surface here. So if I draw the surface here, put an arrow on it, this here is sloping, so we'll put an arrow here saying it's sloping down the way. Now we're told in the question it's sloping at 20 degrees. So to set up an auxiliary vanishing point, we go from our spectator and we're setting it off this line here, which we used originally to find VP1. So we're going to set up an angle of 20 degrees. So we're going to set off this angle of 20 degrees. So what I'll do here is I'll put this in color so that it stands out. Now you don't have to do this in the exam. I'm just doing it for clarity's sake. So this was the line that we drew to get the vanishing point originally. What we are doing here now is measuring off our 20 degrees from our spectator. And the next stage we have to do is from VP2 create a 90 degree angle, and this will give us the height of our auxiliary vanishing point. So we're going to be taking this height, so if put in arrowheads here, and we call this H1. That is the height of our auxiliary vanishing point. Now our auxiliary vanishing point has to be directly above a vanishing point. So we're going to take this measurement here with a compass and go down to our vanishing point VP2, and directly above it mark in that height. And what we've now found is our auxiliary vanishing point 1. So this is auxiliary vanishing point 1, the position of it, directly above VP2. Now, while we're creating auxiliary vanishing points, we might as well find the second auxiliary vanishing point. So in this question you have two auxiliary vanishing points. So in this case, the second auxiliary vanishing point is directly above vanishing point 3. So again, for clarity, I'll draw this in pen. So this here is the line that we use to find VP3. We will again measure 20 degrees, because we're told in this case here the slope of this surface is 20 degrees. So we mark off 20 degrees. And from the spectator, draw this line, and then from VP3 create this 90 degree angle, and what we've now found is the height of our auxiliary vanishing point, our second auxiliary vanishing point, above vanishing point 3. So if we just draw in a line here, and with our compass we'll take this height and mark above vanishing point 3. This is our auxiliary vanishing point 2. Now this helps us draw most of the question now. So if we want to start using these auxiliary vanishing points, we'll go down to the perspective view now. And what we look at is where could we be using these vanishing points. So the first edge I'm going to look for is this edge here. So this edge here, I know it has to be joined to an auxiliary vanishing point, and this is going to be joined to auxiliary vanishing point 1. Now this one will also be done the same way, and then we'll see this edge here is horizontal, so this is going back to VP1. So to start off this drawing here, we have this edge here, this point here, so we can join this up to auxiliary vanishing point 1. Then from our plan, we've already found the back edge on the picture plane, we've brought it down, and what this allows us to do is draw this edge here at the back. So this is the back edge. We can draw this edge in fully now. What we can do is we can take this edge here, we can vanish it back to VP1. Now we're going to have to find a point where the building stops here. So what we do here is, in our plan view, join the back point that we're looking for onto the picture plane, and then bring it down from the picture plane down onto your object. So this is the point here. So now we have found this point. This allows us to draw this line here now in heavy. Now the next issue now is we have to deal with looking for a height, possibly for the height of this piece here, or we can draw in this line here, which possibly is a good way to approach this question. So we could look at drawing this line in, and then once we have this line drawn in, we can draw this line across and so on. So if we take with this line here and start off with this piece here, and then we can draw in this line and this edge, and then we can worry about all the rest of the details here. So to do that on this drawing, what we do have is we have this point. We know a line comes down here. It is joined to the auxiliary vanishing point. So what we can do in this question here is, from this point, join to auxiliary vanishing point and extend it forwards. Now when we have that done, we can find on our picture plane this point from plan. So find this on your picture plane. So this point here now is brought down, marked off here, and what this has given us now is this side edge here. Now what we can do with this then, we know the front line, the front edge of the building here is horizontal, so this is joined back to VP1. Then we want to know where this finishes, so the easiest way to figure out where this finishes, find it in the plan, bring it onto our picture plane by joining it to the spectator and marking it on our picture plane. Bringing this point down now to our perspective view, and what that has allowed us to do is draw the front edge here. So now what we have drawn is we have this front edge drawn. Now we have a few details missing here, so what we look at is possibly start drawing the top section now, because the top section, if we look at the drawing here, so looking at the drawing here, we'll notice the top section here is a horizontal line, horizontal line. So we know these are joined back to vanishing points. But the only issue about this is we don't have a height for this, so we need to use a height line. So we'll look at how we use a height line, because the height line in this case we have a couple options. So if we look here and we want to create a height line, now this is the edge here, so we could extend on a line out here, but what I notice on my page is that it's probably going to run off my page here. Then what it is, it's going to be off my page down here. So what I'm going to do is, I know it's for this edge here, so what I do know is if I run a height line and bring it parallel to one of the other vanishing points, it would allow me to join this back to the other vanishing point. So what I'm going to do in this case here is VP2 is in this position here, so what I'm going to do is extend this edge out to here, mark it on the picture plane, and then once I have it on the picture plane, I can mark my height line down here in this view here. So what I'll do here is, to highlight this, I'll go with a different color pen and draw a height line. Now in the exam you wouldn't be expected to draw all these things in biro, right, because it does mess up your drawing. So I'm just doing this for demonstration and for explaining the question. So this pink line is our height line. Now we bring this down. And what I'm going to do here now is draw it in heavy, touching off the ground line. So I now know that's our height line. So looking at the question here, and this is why it makes sense to mark on your measurements in millimeters. We now know the top of this structure here is 75 high. So what we do in this question here, on our height line, measure up 75 mils. So 75 mils up, and join back to vanishing point VP2. So this is joined back to VP2, and what this happens to give us is it gives us this back edge here, so this line here at the back, and it will also give us our front edge as well, because both of these have been already found. So what we have here is, I can draw in this edge in here now heavy, and I can draw this edge now in heavy, and dim edges are found by using that height line. So again, just to recap on that height line, this is the height line brought down to plan, mark off 75 high on it, join it back to VP2, and then what this allows us to do is draw this line and also this line at their correct heights. This line is horizontal, so it means it can be joined back to this vanishing point here. Now this front edge here is also horizontal, so it's joined back to this vanishing point here. We have this edge here, so what we do in this case here is join top edge here to VP1, then this top edge then can be brought straight up. So this is the edge drawn up here, and then this edge can be vanished back and drawn in heavy. Now we've only one more edge to find, and it's this edge here. Now this edge is, if we go back up to plan, is this edge here. Now we know this is parallel to vanishing point 3, but what we do notice is this is tilted up at an angle. so it's tilted up at an angle, so it can't join to VP3, it needs to join to auxiliary vanishing point. So that's why we had to find a second auxiliary vanishing point. So to find that, we've found in plan. So to find the line, the edge, all we do now is take this point here and join it to AVP2. And what we have here, this is what it is looking like. So if we can look at what the answer is here, basically this here. Now they're fairly close in these 2 points, but there is a small gap, and it's just because the way it's vanishing back here and the positioning of it on the page. So there's they're not intersecting here. So if you do think they're intersecting here, they're not. It's just that there's about 2 or 3 mils of a gap there. Okay, now that's 27 marks for drawing that section. Okay, nothing too complicated, 1 or 2 new things using 2 auxiliary vanishing points, but using 3 vanishing points in this question. Now the next piece, looking at the chimney. Now the chimney is in position C, and what we have here, it's out here on its own here, it's 25 mils away. So what it is, we need to locate it in the perspective view. So couple things about this, it's not touching any of this, so it will require a height line. So the easiest height line is to create a height line, draw a height line from C, so that we can find it on the picture plane, bring it down to the ground line, and then project it back. So again, with any height line, we need to go parallel to one of the vanishing points. So what we have here is this vanishing point here, VP2. We could take VP3. So in this case here, we'll take VP3. Okay. So what we're going to do here is set up our adjustable set square, and we'll set it up to the angle of VP3. So we'll just slide this up here, set up our adjustable set square, and what we'll do is draw a height line from point C, and we'll use a different color this time. So this is our height line this time. Okay, so our height line is brought from C onto our picture plane. Now it's on our picture plane. We'll set up our adjustable set square to the angle of the picture plane again. Now bring down our height line, and in our perspective view we'll draw our height line. Now, so we've our height line drawn in the perspective view. Now we need to join it back to a vanishing point. Now we brought it parallel to VP3, so we're going to join it back to VP3. And in this question here, what we're going to do is we're going to take this and join the base of the height line this time, because we don't have any base here, so we need to find the base of this tower as well. So we need to bring it back point 0 or height 0 back to VP3, and then we mark the height of the tower. So in this case here, the height of the tower is 100 mils. So we're going to bring the 100 mils back to VP3, and then all we have to do is bring our chimney onto the picture plane. So by joining point C in elevation, or in plan view, join point C here to our spectator, mark it on our picture plane. So if I just set up the camera again, so we have this point found. So this is where it is on the picture plane. And what we can now do is, using our height, so what we've now drawn is, this is the position of the chimney. So the position of the chimney, that's the height of it, 100 mils up in the air, and this is also 0. And you can test your accuracy in this question as well by joining VP1 through the back of the object out to the front here. So that can be also tested, because the back of the object and these should line up, because in the plan view it runs along just a line parallel to the back here for position of C. So if we look here, the back here runs along here. So if we're accurate, we should be able to join the base there back to VP1 as well. Okay, now that's the tower set up, or the chimney set up. Now the last part C in this question, it's a new question that has been asked, hasn't been asked before, but to explain it, all they're looking for is when you're at the spectator point, and this all is drawn in. This is all drawn in the plan view. What they're asking you, they want to know what the elevation of the chimney is when you're looking from point S. So to answer this, the first thing you do in plan is draw a line from S to the chimney. Now what's asked in this question is they want to see the elevation of it. Basically what they want to see is the height of it. So the easiest way to do this is set up a 90-degree angle here on that line. And what we're doing here is we need to, from the spectator, mark off the angle on which you'll see the top of the chimney. Now what we have to remember is, and a lot of students will go from C here, measure up 100 mils and then join it to S. Now that will give you an angle, but it's not the correct angle. The reason it's not the correct angle is the spectator is not on the ground. The spectator is the same height as the horizon line. So that means our spectator is 50 mils up in the air. So what it means then is, to measure up to the top of the chimney, then there's only another 50 mils to measure up. So what we do here is we measure up 50 mils on this point here, and then what we do is join it to S. Now this is the required angle. So if I put it here in pink, and this can be marked anywhere on the page, this here is the required angle. So they want to see the angle of your eye line to see to the top of the chimney. So basically what this is, this angle here is folded down flat. So it's folded down flat. This is the angle in which you have to look up from the spectator to see the top of the chimney. So this measurement here has to be 50 mils only, and not 100 mils that some students would mark it off as, because we have to remember our spectator is 50 mil up in the air. Your spectator point is rarely ever on the ground line. So looking at a whole, that's the whole 2018 question completed. A few new things that haven't appeared before. Unusual that you have a chimney out, or a separate part of a drawing out away from it. Now it is a really simple structure when you look at it. There is only 2 blocks on it. There's no curves, but in order to be able to draw it, we needed to use 3 vanishing points and then 2 auxiliary vanishing points.